Hello everyone, so we're going to start off today's lesson by talking about simple machines. And if that doesn't sound like something that's familiar to you, don't worry, I'm sure you're more familiar than you think. If you ever weighed a fruit on a grocery store scale or climbed up a flight of stairs, then you've taken advantage of simple machines in your life. So simply, what a simple machine is a device that takes in a force and then alters its direction or magnitude, or both. And there are 6 types of simple machines that you should probably be familiar with. There's a lever, an inclined plane, a wedge, a pulley, wheel and axle, and screw. You run into these in your daily life constantly. And how these simple machines work is by playing with a scientific term we call work. The way we get work is multiplying the force applied on an object, how hard I push on it or pull on it, and the distance that it moves, or so like 5 inches or 5 miles. So by playing with these terms of force and distance, but keeping the work the same, we can get a lot of interesting machines. And machines which require you to either put in a little bit of work to get a lot of distance moved by an object, or maybe a lot of work to move an object just a little bit. And this ratio between amount of force put in into the force put out on an object is what we call efficiency. So not all simple machines are as good as one of another. They're not all equal. So if we have a machine where we put in a little bit of force and get out a lot of output, a lot of force on the other end, then that's a pretty efficient machine. But however, if we have to put in a lot more work, work on our end and get only a little bit of result on the other end, that's something we would say isn't very efficient. Well, that's enough talking. I actually have an example that I'm about to show you with levers, and I'll show you in a sec. Hello guys, so we're back, and what I've done here is constructed one of our 6 simple machines. This is a lever, which I've just put together with some household items. You can do it yourself if you want. So what I've done here is constructed a lever with a piece of cardboard and a pencil. And I have some weights here to show you exactly what this lever is going to do. So the definition of a lever is a rigid bar, or piece of cardboard, which pivots around something called a fulcrum, which is just a fancy word for the pencil right here, which this bar moves around. And when given a force on one side, we'll get a reactive force on the other side. So, and the amount of force that we get on one side relative to the one we put on the other side is determined by where we put this little pencil right here called the fulcrum. This is the magic of it all. So right now we have our fulcrum in the middle. So the amount of force I put on this side is equal to the amount of force which is going to be pushed up on this side. So you see I have 2 weights. So I have one weight pushing down here, one weight pushing on the other side with the same amount of force. So they just cancel each other out. And we have equilibrium, as we would call it. But if I put a little bit more force on this side, you see that I quickly shift the equal forces and we lift on this side. Alright, so in this next part, I've shifted the weights around. And you can see that we have one weight being able to push up all 3 weights. And this goes back to, this may seem a bit odd, but this does go back to the whole fulcrum thing I was talking about. Since I put this fulcrum closer to the load of weights that we're trying to raise up, it actually becomes easier for us to pull up these weights using a smaller amount of force. So here's another example. So what I've done here is I moved our load that we're trying to pull, this one little weight, far away from our fulcrum. And you can see the difference it makes in the efficiency of this lever. So I have to use 4 weights just to be able to lift this one weight. And that's something we would describe as very inefficient, because the amount of weight that we're putting in, or the force we're putting in on this side, is not equal to what we're really getting on the output on the other side. We'd much rather prefer our previous example where we only had to use a little bit of weight to actually lift a lot of weights on the other side. Well, that's the end of the demo, guys, but I hope you enjoyed watching. You can even construct this at home if you wanted to. Like you see, pretty simple. You could use a pencil and a piece of cardboard and whatever you want as weights, maybe coins. Well, I hope you guys give it a try.